Alright, so I don't know about you guys, but I had a lot of fun building this 450 as a racer. But it got me thinking. As nice as this cylinder is, as much potential as it has, and as much as I really wanted this clamshell to work, I don't think this is going to be our best idea for an all-out race saw. I think we could definitely make it quicker, and it'll be an awesome test bed for carburetors, cylinder heads, everything else. But I think our normal split case, bolt-on cylinder, is going to be the best option. So with that being said, I have a pile of these Echoes still. This one, CS 4500 that we tore down, but it's pretty much the same exact thing. It's a CS 5000. I'm sure some of you have seen these before. But I want to go over, but we're going to do a crank swap. This one, it's already done. I'll show you how we got here. But I want to go over a crank swap, and I want to look at some cylinder options, and I want to get some feedback from you guys. Good. I'm all new into this stuff. I just enjoy putting my Legos together. These are kind of Legos, Connects, and Tinker Toys. We'll mix them all together and we'll make something. At least if it runs, that's a win. And we'll try and make it gradually faster. This is the CS 4600. They had a 4500. They even had a 4000. But 45, 46, and a 5000 was their 4550cc lineup before this clamshell style. Now this one, still a mag case, but it's the older style split case. You can see. There you go. You can see this one's been sitting somewhere, getting dirty quite a bit. I've got more handles. I've got a lot of parts for this chassis. But today what we're going to do, we're going to strip it all the way down, split the case, and I want to see what it's going to take to put a larger crankshaft in it. But first I want to get this crankshaft out, see what it looks like. Now we're just going to do a super quick teardown on this. I don't know if it has the date on it. This is actually a CS 4500. It's a super similar chassis with all of them. This one uses T25 fastener. And no real reason to use these. I mean, nobody else ever has. There's probably a reason for that. But I want to try something different. And it's plenty solid enough. Plenty solid of enough design to hold up to it. Pull the throttle rod out. Let's see if we can read the tag. It says 155 PSI, has spark. Echo 4000 or 4500. 4/22/2015 is the tag date. So this one's been sitting for a while. Oh, whoops. Don't tell anybody you broke it. Let's try that. There we go. Much better. I wonder, I might have to use one of the later 5000 cases that I have. I don't know if they all have this style ignition or not, but we'll knock this flywheel off. Alright, got the flywheel knocked out of the way. Alright, so, see, these ones use a tiny exhaust and a tiny intake port. They can be made to run okay, but they're never gonna really run like some of the others. Now, these are pretty much same exact chassis design as all the other Echoes, the 680, the 8000, the older ones anyway. There we go. A aligned to the manual oil pump. Even this little bitty saw, it's got a manual override for the oiler. Pull the carb box out of the way. Alright, now we should be able to get this tank out of the way. Alright, now that is a nice thing. This chassis is pretty modular. The way that the carb box bolts on. Like so. We can get rid of this piece. We can get rid of that piece, open up this carb box, and we got a nice wide area to fit all sorts of different carbs in here. Let me clean this up a little bit, clean that up. Then we'll get it split to look at the crank. Mostly cleaned up. We'll pull this coil. We'll pull this ignition stuff off real quick. Sounds like we got some oil in the tank. We'll drain that. Oh, yummy. More like snot in the tank. That's some pretty yummy looking oil. Let's go pull that out. So we got that all flushed out. We'll see if we can pull this cylinder off. Now this build definitely going to take longer than the last one. We're just going to fit it in here and there. But after racing the clamshell, it makes some power, but it's definitely not on par with some of the other saws. So that's another interesting thing. You'll notice no base gasket on these early Echoes. They might have put a little bit of sealant on there, but there's no base gasket and no real trace of like a thick silicone either. So that's definitely something on these early Echoes. Like piston, great shape, but that's something you don't see very often. Let's pull this piston off real quick. All right, get that pin pushed out. Let's see. Now we'll go get our K-splitter, see if we can pop it apart. Alright, this is just a Husqvarna K-splitter. We'll see if we can get it fitted down in there. There she goes. And there we have it. 131mm stroke crank. Let's pop this other side out real quick. Hey, look at that. We didn't even have to pop it out. That'll actually come in extra handy. Alright, so there's our crankshaft. So this is 31mm stroke. Now we're going to look at some longer ones. Right there, CS4500. That's the chassis we have. And I'll tell you now, we've already machined it. This is actually a CS590 Timberwolf crank. This is my original plan, and it fits, it works, it would work. But what we have. But today I just wanted to go over some stroker options. This is our factory crank here. Factory crank, 31mm stroke. We have a 36mm stroke. And of course, you know I had to fit the big one in first. This is a 37.6mm stroke CS590 crankshaft. And this is still our little 50cc case. So, the plan is to build a race saw off of this case. Maybe not this exact one, but this chassis, the 4500, 4600, 5000. That chassis, just like this one. And that'll just give us more options, more stable platform. These cylinders here are all some other than this one. These ones are all 3 cube options, which we'll get to in a minute. But I just wanted to show, I'll show a clip real quick, how we set these up in the borer machine, bored out the cases. can see that boring machine does a pretty slick job of these cases. We made a centering cone to line up on the bearing because the fingers wouldn't reach the center in the case. You can see plenty of room to seal. So it's definitely getting a little thin. But we're only talking about race saw stuff. And here it is with the bigger crank in there. We turn this down. I'll show you the clip of turning this crank down, getting it all fitted in. Yes, this will affect the balance, but we can address that later if we absolutely need to. Even if we have a little bit of a step left over, we can go through, grind that by hand. But with the way my cable's pulling the rod, it's definitely leaning this side. So I just don't want to hit that rod and have it spin and everything else. And we did have to thin that rod. So you can see that rod's definitely on the thin side. But I ordered another crank. I ordered another crankshaft, and we can go a little bit more on this bore. Now with this big crank, we have to go with a 41 millimeter bore. 41 millimeter bore, 37.6 is like 49.8 cc's. So we're under that 3 cube limit. So that would work, but there's not very many great 41 millimeter bores. Most all of the good looking cylinders are 42 or bigger. So what's that mean? That means that we can't economically use a plated bore. But what we're probably going to end up doing, dropping down to a 36 millimeter stroke, which is what that is. And it's already set up for the more common 10 millimeter pin. Then we can use these more common 42 millimeter bore cylinders. So 36 millimeter stroke, 42 millimeter bore. It's like 49.9 cc's. That's right there at our 3 cube limit still. Now why are we bothering with the long stroke, small bore? Well, that's all to do with the time area. You can get more area open in the same amount of time with the longer stroke. And since we're talking race saw type stuff, we're going to be maxing out the port widths and everything else. So that long stroke with the movements, everything's happening at a faster rate. You're traveling further, it's opening the ports more at a faster rate. And who doesn't like to say that they have a stroker? And now there's a couple of ways that we can do a stroker. So we've already talked about the crank swaps. You could, let's move in a little bit. Could take the crank, press it apart, weld the bottom half of the pin bore, and offset bore this for a little bit extra stroke. Press it all back together, true it all up. Or you could find a rod with a larger big end diameter and a larger pin, and you can offset grind those pins. Then when you press it together, you put the offset up. That way you get more effective stroke. Or you can go the easy route like we're doing and do a whole crank swap. So let's look at these a little bit closer. We'll start with the 36 since that's probably the one we'll end up using. Alright, so here's the 36 on the bottom and our stock crank on the top. Now if you notice, you got the bearing journals, which both of these are going to be the same on the bearings. This notch here, that's a cutout for the old oil pump drive. What we'll end up doing, you can see this is the bearing area. This is where the worm rides for the oil pump. There it is. We'll throw the worm on there. You see, bearing, seal, worm, clutch bearing, outboard clutch on the stock crank. So all we have to do is mimic that. We got the bearing, but what are we going to do with this notch? Well, what we're going to do with that notch is we'll turn this diameter and we'll put a sleeve on there. We'll shrink fit a sleeve and we'll grind that down on our OD grinder for the seal surface and the worm. Okay, so that gets this part. We got the bearing, we'll have the seal, we'll have the worm. That'll all be on a pressed on ground sleeve. And what are we going to do here? We'll turn these threads off, keep this journal. And what we're going to do is we're going to go back to our clamshell. If you notice, that CS450 uses a smaller diameter clutch thread than the 4500, 4600, 5000 right here. So what we'll do, we'll take this smaller diameter clutch like that. So we'll use the smaller diameter clutch, extend the threads into the journal a little bit, grind off these threads, and that'll be our bearing area. And we'll just use the bearing, drum, and clutch off the late model, easy to get, CS450. Already has the same size bearing diameter. Everything else, we just need to move it in. Just a little bit. Let me hold up the other one. You can see we're not talking about a whole lot. Just need to move it in about a 1/4 inch. That's all. But swap into this smaller diameter clutch thread, smaller diameter bearing, will allow us plenty of material on this crankshaft to do everything we need. Swap everything over. Then on this end, on the flywheel side, all we have to do on the flywheel side, shorten the shaft, put the taper on, and put the threads on. But we got plenty of meat and material to do that. And like I said, this is all on the 36mm stroke crank. Now the neat thing about the Timberwolf crank is already has the right taper, already has the right thread size. On the flywheel side, it already has the right taper, already has the right threads. It's just slightly too long, but the web width is the same. Plenty of meat here for the bearing, seal, and the worm. And we can do the same thing. Grind these threads down, thread the end for the 450 clutch and bearing. And this 37.6mm stroke crank would be ready to drop in. Alright, now where does that leave us with build options? With this super long stroke crank, we could go 47mm and make a real nice 4 cube. But that's also going to involve sleeving a cylinder. I think we might just have to do that. So there's nothing wrong with sleeving them. They are just a little bit slower. That iron is more friction than the plating, more wear. And if we're talking about a race saw, we're hoping to eventually work our way up to being fast. It's the only reason I don't want to do the sleeve, just because they're a little bit slower. But if we have to sleeve it to get where we need to, guess we could do an aluminum sleeve, chop the head and have that plated, because we still can get them plated if the heads are off, if it's an open bore. Or we can get another 36 millimeter stroke and use a 48 millimeter bore. That'll give us 4 cube as well. And there's lots of 48 millimeter options. Then the other fun thing with this, use the extra long stroke of the 590 and put a 52 millimeter top end on it. That'll bring us just shy of 80 cc's, right there at 5 cubic inch in a 50 cc chassis, which I might have to do that one. Let me know what you think, just so I can one up my 590 builds. Get 80 cc's plus out of a 50 cc chassis, just because this crank does fit. I don't know, maybe we'll try going all the way to the 56 millimeter, see what that looks like. But I don't know if we'll push it that far. But my main goal is going to be 3 cubic inch 50 cc fast. I want to blow our other race out of the water. Then, and I'll probably do these two at the same time, build a 3 cube and a 4 cube. But let me know which one you think, 36 by 48 or the long stroke and sleeve it. Probably going to go 36 stroke 42 bore for our 50 cc. And we'll look at some of these cylinders I have here. This is an 030 cylinder, 42 millimeter bore. Those are some pretty large transfers and all sorts of real estate for finger ports. Chop the head off, make our own chamber. And these are already set up for a slightly longer stroke. Here we have the tried and true Husqvarna 346. People have been making these fast for years. Then, this is the Partner 5000. Another one people have been making super fast. This is kind of a neat one here. This is off of a John Surette, I do believe. 44. The problem with the Partner and the John Surette are these will need sleeve down to 42, because they're at 44, 45 millimeter right now. But man, those ports, looks like nice big ports, nice large transfers. There's something to be said about getting the charge up to the top. And just for a chuckle, here's the factory cylinder. Itty bitty intake port, itty bitty exhaust port. And transfers are not horrible, but they definitely wanted the longevity out of this one. I don't think there's any reason to really try. Don't think any real reason to try the stock one. I just wanted to go over some of these cylinder options. Wanted to get these ideas out there, just see what you guys think. What sounds like a fun build to peck away at in the next couple months. But the other neat thing, hard to tell, but we put a bushing in this Echo rod, narrowed it up a little bit, and I'll show you how we made that bushing. That's what we started with. That's the inner race of a ball bearing, and that ID is what we need for our normal 10 millimeter wrist pin. So what we're going to do, we're going to grind down the OD to fit our connecting rod. .50 cc saw with 90 cc's worth of stroke. I put that bushing in there. I'll pull it up so we can see. Yeah, it's a little short right now, but I made it size for size. That way If we do use it, I can come in with a carbide. I could pop a hole in there, and there for the oil holes. Well, let me know what you are. Are you team long stroke or are you team longer stroke? Or should we just not even mess with the strokers and leave the stock crank in there? Let me know what you guys think.